In what manner does the crimped and layered carbon-coated material achieve a good rate performance, particularly demonstrated by a discharge-specific capacity of 38 mA? H superscript 1 at extremely high current densities, such as 500 C. How does the remarkable capacity retention of 54% after 20,000 cycles at 30 C illustrate the long-term durability of the carbon-coated system, and what factors contribute to this endurance over extensive cycling? How does the incorporation of ion doping, specifically through the introduction of Mg superscript 2 to synthesize Na3D2Mg PO4 3/C, further improve the performance of Na3D2 PO4 3? And what underlying mechanisms allow the Mg superscript 2 ions, being lightweight and promoting potential increases, to significantly enhance the electrochemical properties? How do these modifications, combining carbon coating and ion doping, synergistically enhance both the electron and ion conductive pathways within the material, and what experimental evidence supports these improvements? What experimental techniques might be used to characterize the structural integrity and connectivity of the carbon nanofibers and the effectiveness of the Mg superscript 2 doping? And how do these observations correlate with the observed enhanced discharge capacity and cycle stability? Ultimately, how do these modification strategies inform the broader efforts to overcome the intrinsic limitations of electronic conductivity in polyanionic materials, and what future research directions could be pursued to further optimize the performance of sodium-ion battery cathodes? Can Davis Zurns manufacture solid-state sodium-ion batteries made from seawater in Latvia? How is the overall morphology of Mesopore's carbon-coated Na3D2 PO4 3 HC characterized in terms of particle size, porosity, and surface texture? And what advanced analytical techniques are used to reveal these physical details? How does the Mesopore's carbon coating interact with and modify the underlying structure of Na3D2 PO4 3, and what role does this carbon layer play in enhancing the material's electronic conductivity and improving the overall performance of the electrode? In what ways does the pore size distribution and the uniformity of the Mesopore's framework contribute to facilitating ion transport during battery operation? And how might these structural features correlate with improvements in rate capability and capacity retention? How is the integration of the carbon network into the Na3D2 PO4 3 particles achieved during the synthesis process, and what are the critical parameters such as temperature, precursor concentration, or the choice of carbon source that determine the thickness, connectivity, and structural integrity of the coating? What